Algebra 2, this is the video for 2.1, representing relations and functions. So before we get into reviewing what a function is versus a relation, I just want us to make a table and graph this little equation that we have here. So we see that y equals 3x minus 5. So we have our table set up already. I chose some x values, just some random ones. So let's go ahead and plug those in. 3 times negative 1 minus 5. It's going to be negative 8. Plug in 0. 3 times 0 minus 5 is negative 5. Right? 3 times 2 minus 5 is 1. 3 times 5 minus 5 is 10. So we would have these points negative 1, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So we should label our axis here. It looks like we got a 10 in both directions. 0, negative 5. 2, 1. And 5, 10. Okay, when it says label your axis with the numbers, I really only need to see those at the ends so I can tell which scale you used at any given time. So there we have our dots, and we could certainly connect these with a nice straight line if we wanted to, because maybe that's how this function works. It could be a discrete function where we just leave it as the dots. So this would be if we know it's continuous. This would be if we know it's discrete. So I guess because I gave you a table, maybe we should call this one a discrete graph. Okay, so let's define a function. You should remember this, hopefully from Algebra 1, but a definition of a function is for every input there must be exactly one output. And I used the wrong there, so I'm very sorry. For every input, there must be exactly one output. Okay, functions we typically represent as mapping relations, which are kind of these little circles, red circles that you see down in the bottom, tables that we just saw, graphs that we just made, sometimes equations. There are occasions where you see them as like this weird little input-output function that you see off to the right here. We don't usually draw those pictures like that in Algebra 2 or anything like that, but it can happen. Okay? Important for you to remember that the domain is the set of all possible input values. Usually these are your x's. The range is the set of all possible output values, or your y values. Okay? That's, of course, when we're graphing on a coordinate plane and we're using x and y. When we have domain and range of a mapping diagram, sometimes they're not even numbers, so we wouldn't refer to them as x and y. Down here, I've labeled this oval as domain, this oval as range, and maybe we can write our functions. So that just means I start at a domain phrase and I go to a range. So what happens if I turn the key? Which of these things might happen? Well, maybe turn key goes to a car starting. Okay? Inserting quarters and pressing a button, maybe we get a soda pop out of that. If you do your homework, you probably earn your points. So that's how a mapping diagram works. Over here on the right, that function machine thing says if we input $1 up here at the top, and this function machine does whatever it is, and it kicks out a prize. That's kind of like a function machine. Okay, mapping relations. Let's look at these two mapping relations and determine which one represents a function. So remember, our definition for function is every domain or input has exactly one output. So check that out. Which one do you think? I bet a lot of you said A was probably a function. So let's see. A is a function because each input has exactly one output. 2 went to -3, 3 went to -3, 4 went to -5, all is good. B, if you thought B, I tricked you. B is not a function because 4 goes to both values -4 and -5. So B is not the function. Okay, what if we look at numerically or as tables? How do we figure out which one represents a function? So take a second to look at that. We have tables here. Check out A. Could A be a function? No, because 5 goes to 12 and something else. Not B either, because we have 2 that goes to 4 and 2 that goes to 8. So C is our function represented as a numerical table. Okay, what if we look at graphs? Graphs, is A a function? Maybe. Is B? How about C? How do we know? You're thinking maybe A is a function. Maybe B. C? Possibly. D? Yeah. E? How do we know? Remember the vertical line test. If a vertical line, some x equals a number, touches a relation more than once, it is not a function. So I have this little vertical line here that I can use to figure out whether A is a function or not. So I can use my vertical line and kind of pass it through that entire function, and it didn't really touch more than once. So I'm going to go ahead and say that A is a function. Okay. And then it said, well, our question was not a function, so not A. Let's check out B with my vertical line quick. Just scan it through there. Yeah, it looks like it's only touching once. How about C? Run it through there. A little questionable right there, but I think it's just super, super close. Still only touches once. Okay. Parabola, looking good, passing the vertical line test. And so that leaves this one, and that one kind of just fails the vertical line test miserably. So our answer is E is not a function. All right, so this one is not a function. Function notation is pretty important. You will see that a lot in Algebra 2 and beyond if you haven't already. So function notation just uses this f of x or whatever your function has to be or happens to be named. We could have g of x as our function's name or h as our function's name. There's lots of different variables we could use. F just happens to be most common. So the way we read this is f of x. It's not f times, that's not right. F of x, or you could say the value of f at x, if that's a little confusing. So what it tells us to do when we have f of 8 here is it's telling us that x gets replaced with 8. So we are going to plug in 8 where the x is into my equation. So -2 times 8 plus 5. Then I use PEMDAS, and I find that f of 8 is equal to -11. I can do the same thing with -3. So now x is going to be replaced by -3. Check that out. -2 times -3 plus 5 is positive 11. So I would say f of -3 is 11. This is not a multiplication. We're not distributing a -3. Don't get any crazy ideas in your head. Okay, we're just replacing the x, because that's the variable. We're replacing the x with whatever is inside. Okay, and the last one is f of 0. And f of 0, we replace 0 with, or x with 0, and we get 5. So there we have evaluated functions very quickly. It's not a hard process. You just have to remember that that value replaces all x's inside the function. Domain and range, super important to review yet again. So here we have a relation, all these red dots on my coordinate plane. I used a scale of 5 and I kind of messed up the labels, they're a little off. But I used a scale of 1, so I go from 5 to 5, okay? And we want to talk about what the domain is. Domain, input, or x. Okay, so you look at all of the x values of these points. So this first one, far off on the left, looks like we have a -3, and there's a -2, a 0, and then we have this and this at 2. So those values should be my domain. Range then is going to be the y values, so you just go ahead and check out your y values. I always work from left to right for domain and bottom to top for range, so they're in numerical order. So this lowest y value is a -3, and then a 0, a 1, 2, and 3. So there's our domain. Notice they are drawn in those funky little curly braces. Okay, do your best to draw them. Don't think you can use any other symbol. Do your best to draw those little braces. I know it's a little challenging, but you can do it. Okay, the final question there about this graph is the relation a function? And then tell me why. So we could use vertical line test. You could use, just the fact that you can see that there's 2 x values where 2 is, but no, it doesn't pass the vertical line test at x equals 2. That is the easiest when you're looking for a graph. Okay, one more practice at evaluating functions. So perhaps you should pause the video right now and try evaluating this function, 2x squared minus 7x, for the values of 0, 3, and -2, and see if you get the right answers. Pause now. Okay, welcome back. Did you get f of 0 equal to 0? Because we plug in the 0 for the x's, and we get 0 and 0. How about f of 3? Did you get -3? Good work. How about -2? That one might be a little tricky. Squaring that negative kind of messes people up sometimes. If you got 22, you got the right answer. If you didn't, I'm guessing your mistake was right here where you forgot to make that positive or maybe typed it in wrong. That's all I can tell you about functions today. Let me know if you have any questions, and I'll see you tomorrow.